Good morning. I just wanted to go through a couple more problems on this exponential equations and logarithms worksheet or workbook page. It's page 125 in your workbook, so you should be right there with me. We already did a couple of these. I believe that we did 1, 2, 9, and 12 already together. So I just want to go back and refresh your memory on how to do these to help you become more independent with them. So if you remember, we had talked about how when we looked at exponential equations before, they were usually kind enough to give us something like 9 to the n equals 27. And we said, well, both 9 and 27 share a common base of 3. And so we could rewrite this as 3 to the 2n equals 3 to the third, and we could just solve like that. But there are situations that we're going to run into where these two bases that were given, again, this is really technically the base, although we could imagine the 29 as having an exponent of 1, which case would make it also a base, but we would note that there is nothing that they have in common. 29 is a prime, so there is no way that we're ever going to get some factor of 9 and some factor of 29 being in common so that we could get the same base. And so we said we had to use the calculator to do this. But the first thing we did was we said whenever we're stuck with exponentials or logarithms, try writing it in the other form to see if it makes it easier to solve. And so in this case, it's already in exponential form, and we're going to rewrite it in logarithmic form. And so for us, that means we're going to take this base of 9. Again, the base of the exponential becomes the base of the logarithm. So we've got log base 9, and then these two are going to switch. And so we're going to end up with log base 9 of 29 equals n. All right, so this becomes the base here, and then these two flip-flop, the 29 and the n. All right, now from our work using the change of base formula, we say, oh wow, I can use the change of base formula to change that base into something that my calculator can do. And so I'm going to choose to change it into log base 10. And I do that by writing log base 10 of 29, or just log, as I always say there, over log of 9. And then we use our calculator. Before I do this, I'm going to estimate and say how big do I think n is going to have to be in order to get 29. Well, 9 to the first is 9, and 9 to the second is 81. 9 is too small for 29, and 81 is too big, so it's going to be somewhere between 1 and 2. And specifically, I think it's going to be closer to 1, right? Because 9 is much closer to 29 than 81 is to 29. So let's just go ahead and do that then. So we're going to have log of 29, make sure you end your parentheses, divided by log of 9, and we get 1.5325. It asks us to go to the nearest 10,000, so I'm going to make sure I put those 4 decimal places in here. So I get 1.5325, and that is the value of n that I was looking for. And again, if you're not feeling super confident, you could always go back and plug that in just to make sure that you do get 29. So let me just do that. 9 to the 1.5325 power. Yeah, it gets me 28.998, so very close to what we anticipated. Okay, let's look at, again, that was just a refresher on how to do these. Let's go down and look at problem number 10. Because in problem number 10, again, we had looked at number 9 and number, I believe we looked at number 12 also. But in these, we noted that there was an extra thing in here. There was this -8 that is acting as a coefficient to this, right? And so we said, just like if we had 3x equals 21 and we wanted to solve it, we would divide both sides by 3 to get the x by itself. And essentially, this is where our x is, and so we're trying to get rid of everything that's not part of that. All right, so I'm going to divide both sides by -8. So I get 9 to the -5x equals -49 over -8, which I'm just going to write as 49/8. And you might be tempted to let your, to come up with a decimal approximation. I would say just leave it like that and let your calculator do the work for you in just a second all at once. All right, so again, when we're in a situation like this and we don't know what to do, then we say let's switch it into the other form to see if it becomes a little bit more obvious. So I'm going to rewrite this exponential as log base 9. Again, it's just coincidence that the problem that we just did also had a base 9. It's not always 9. It's just whatever this base is right here. And then we flip-flop them. So this becomes 49 over 8 equals negative 5x. Again, before I start punching any buttons, I'm going to, well, actually I can't punch any buttons yet. I have to do the change of base formula. But first I'm going to ask myself 9 to what power would give me 49/8. First of all, I don't know what 49/8 is, but I know that 48/8 would be 6. So 9 to what power is going to give me something close to 6? Well, 9 to the first would give me 9. This is less than 9. So I'm expecting a fractional answer. All right, but again, I'm jumping ahead of myself. Let me clear a little room here for my additional work. All right, so when I do this with the change of base formula, I'm going to write log of what we were taking the log of before, 49/8 over log of 9. And this is negative 5x. Again, last time we didn't have to worry about that so much because that's just what log base 9 of 29 was. But here we can't forget that this is a negative 5x equals this. All right, so let's do that on the calculator. So log of 49/8 divided by log of 9. And I get 0.8248 equals negative 5x. So again, our approximation that this is going to be less than 1 is accurate. Now we just have to solve by dividing by negative 5. So I'm going to take this negative 5 here, and I'm going to end up with x equals, I'm going to divide by negative 5, and I get x equals negative 0.164, nope, that's going to round to 50. Now, I just did something where I just kept the answer that was in here and I divided by negative 5. If you cleared your screen and divided by 0.8248, or divided 0.8248, divided by negative 5. Sometimes you'll get the same answer. Sometimes your last decimal might be off. So negative 1 point, no, it's going to be the same in this case. Negative 0.16496. I go to the, I want to round to this place. This is higher than 5, so I have to round up. But sometimes if you do that and you don't clear, you get a little bit of a different answer. So, okay, let's flip to the next page. And I would like to look at 13, 17, and 19. All right, so again, like the last problem, we have additional things here, either added, subtracted, multiplied, or divided into this, right? So we need to move that. So I'm going to move that by bringing the 5 over to the other side. All right, so I end up with 5 to the 4x equals 91 minus 5 is 86. Right, I'm going to rewrite this in logarithmic form. So think about that for just a second. What would that look like? All right, hopefully you said that that would be log base 5 of 86 equals 4x. All right, I keep the base here and then I flip-flop these two. So now, again, the question arose before about how do I know when to expand and condense, and how do I know when to use the change of base formula. Again, change of base is when you know both the base and what you're taking the log of. There can't be any variable in either position there. So this is a perfect candidate for that. So we've got log 86 over log 5 is equal to 4x. Again, before I punch anything into the calculator, I'm asking 5 to what power is 86? So 5 to the first is 5, 5 to the second is 25, 5 to the third is 125. So it's going to be somewhere between 2 and 3 is the answer that we get for this. All right, so let's do that. Log 86 divided by log 5. And we get 2.7676. So 2.7676 equals 4x. And I'm going to divide that by 4. And I end up with x equals 0.6919. That's my answer. And again, you can try that out and make sure that it gives you a good answer. If I do 5 to the, and now I'm going to put it in parentheses here, 4 times 0.6919, end parentheses, and then plus 5, that should get me 91 or something very close, yeah, 90.99. Okay. The next two that I want to do, you should notice a change here in that we stop using just our good old-fashioned numbers here, and we switch our base to an e starting around problem 15. 16 is still the old type, but from 15 on we end up with bases of e. I've picked what I think are the two hardest ones on the sheet because they involve decimals, and so I just want you to not have to worry about doing those independently. So let's just go through and solve these. All right, so in this case, again, I see that there are some additional things besides just the log or the base right here. So our base here is e to the, our base is e and our exponent is 10x minus 8. The additional things are this 5.9 being multiplied it and the 0.7 being added to it. And again, if we think about if I have 5x plus 1 equals 26, what would our order be that we would do here? Well, we would subtract the 1 first, and then we would divide by 5. All right, so when we go and look at this more complicated one, we're going to do the same thing. We'll subtract the 0.7 here, and then divide by 5.9. All right, so when I subtract 43 minus 0.7, I end up with 5.9 e times e to the 10x minus 8, and this is 42.3. Now I'm going to divide by 5.9, so I have e to the 10x minus 8 equals 42.3 divided by 5.9 gives me, I'm going to go out to 4 decimal places here again, so I get 7.1695. All right, so again, it should remind you of when we were at this stage right here for our prior problem where we have base, an exponent, and a number. Here we have a base, an exponent, and a number. The part that's weird is that our base is not 5 like it was before, it's e. But that doesn't matter, the same thing is going to happen. We're going to take, and just like we did here, how we wrote this in logarithmic form, we're going to do the same thing here. Again, the part that will feel a little bit weird for you is that we have this e, but we just have to remember that when we write this as a logarithm, it becomes the base of the logarithm, and then these two flip-flops. So 7.1695 equals 10x minus 8. Now, this part is not how we normally write it. We would really write this as natural log of 7.1695 equals 10x minus 8. All right? So instead of leaving it with that e explicitly written, we write it in its just its special form, which is natural log. Now, at this point, any mental difficulties that you might struggle with right here in terms of what do I do because it's e, it's balanced out by the fact that now when we go to do this on our calculator, there is no change of base formula that we need to do. There is a natural log button on the calculator. And so at this point, we just go right into doing natural log. Actually, I should pause for just a second here because normally at this point we estimate. It's going to be a little bit harder to do because we don't really have a lot of intuition when it comes to e. But if you remember, e is approximately 2.7. And so 2.7 to the first power would be 2.7. If we do, 2.7 to the second power, that's about 7.29. So if we think about it that way, our answer should be pretty close to 2, but just under 2, because e to the second power is around is around 7.29. We're a little too small here. So when we get this answer, we should expect it to be around, 1.9 or something. So let's go back here. Natural log of 7.1695. Yeah. 1.9698, so I'm going to write that as 1.97. No, I'm not. I'm kidding. I'm going to write that as 1.9698. I was thinking I was rounding to this place, but when I round to the 10,000ths place, it stays an 8. All right, that equals 10x minus 8. From here, it's easy. I'm just going to add 8 to both sides. So I'm going to get 9.9698 equals 10x. And then I'm going to divide both sides by 10, which is going to change. The dividing by 10 is just going to move the decimal over. So we end up with 0.969, nope, 0.99698 equals x. And now when we round to the nearest 10,000ths place, this becomes 0.9970 equals x. All right, I'm a little concerned about time. It might cut me off, so if it does, I might ask you to just finish this one on your own. But again, we're looking at additional things that are added to, multiplied by this right here. We need to move things over. So first we're going to subtract 2.9. So we're going to get negative 5.3 times e to the 8x plus 5 equals, it's going to be negative 29.9. Divide both sides by 5.3. So we get e to the 8x plus 5 equals, let me do that, 29.9 divided by 5.3 is 5.6415. I'm going to rewrite in logarithmic form. So again, just like last time, this is going to be log base e of 5.6415 equals 8x plus 5. Again, I'm just going to replace this with natural log of that. This one, if I take 2.7 to the first, I get 2.7. If I take it to the second, we know that's way too high because last time it was about 7.29. So when we do this, we should expect something between 1 and 2. So natural log of 5.6415. Yep, we got 1.7301 equals 8x plus 5. I'm going to subtract 5 from both sides, and I get 8x equals negative 3.2698. Yep. And divide by 8. Divide it by 8. And I get negative 0.4087, if I'm reading that correctly with the glare. Yep. Okay. All right. Hopefully you can handle some of these on your own. All right, bye.